Hello, my name is Tracy. I am the Application Chemist here at Defiant Technologies. Today we're going to talk about calibrations. For the purpose of our demonstration, we're going to be doing a calibration with water. Okay, a water calibration can be used for groundwater or can also be used for soil. Okay, the basic process, however, for air is not any different. You're just going to be doing samples with air. Simple as that. The very first thing that you want to do is run a blank. You need to start with a good, clean baseline. Sometimes you might need to run more than one blank, maybe 2 of them or 3 of them. Okay. You want to use distilled water or preferably DI water. Deionized water is your best choice. Distilled is also good. Tap water is not your best bet. It probably is going to have some contaminants that might show up on your frog. So after you've run a blank using DI water, then you're going to run an injection. Okay. The purpose of this is to run known samples of concentrations of your analyte. Okay. Here today we're using MTBE and BTEX. Okay. So you want to run known concentrations, and we're going to use those known concentrations to build a calibration file. Okay. Here at Defiant, we prefer to use a minimum of 5 points for our calibrations. We strongly recommend that you use a minimum of 3 calibration points for a linear fit or 4 for a quadratic fit. Okay? If you don't know what I'm talking about, just bear with us. We're going to go cover that in detail. Okay? So after I run a blank, this is a 5 milliliter glass syringe. I'm going to fill it up with deionized water. Make sure that's exactly 5 milliliters. Okay, just gently push that plunger right to the 5 milliliter line. Okay, then I'm going to take my standards. Okay, folks, if you're not sure about the standards, please make sure to see our video on serial dilutions. Okay, that will explain to you in detail, step by step, how to get different concentrations of your analyte so that you can do a good cal. Okay. You'll notice that this microreaction vial has red and a green. Red is keeping it closed. We're going to switch it to green to open it. Okay. This is a 10 microliter syringe. We like to get ours from Hamilton. The first thing you want to do is clean this out 3 times with methanol, and then you want to prime it. Okay, so this has been cleaned 3 times with purge and trap grade methanol. Okay, to prime it, with a smaller syringe like this 10 microliter, I just fill it up and dump it out. Now I'm going to pop it back in. Okay. Folks, if you're not comfortable with the use of these microliter syringes, we do have a link to a video that covers that in detail. Okay, you do want to use good lab technique for calibrations. The more accurate your concentrations are, the better your calibration is, the better your data is going to be. Okay, it's worth your time to clean your glassware, to learn how to use this type of syringe correctly. All of those little steps will add up and will give you excellent data. So now we're going to fill this up. We're going to make sure we get rid of any pesky little bubbles that might be in there. And then I'm going to measure out 2 milliliters of analyte. Once I've got that measured, this needle just goes in the top of my 5 ml syringe. Push down the plunger, ready to go. Now, I'm going to take my sparge bottle, slide it right over that needle, okay? It needs to be in the down position. This syringe has a luer lock fitting. It just screws right on there, okay? My valve, of course, is in the load water position. Depress the plunger. Okay. Now I can put the sparge bottle up, tighten it. No wrenches needed, folks. Your hands are the perfect tool. Turn that valve to run water. Okay. And then all we have to do is press play. Okay, make sure that you use this notes field to document exactly what concentration you just used. All right, folks, after you've run that first injection, you're just going to repeat those exact same steps, okay? But each time you're going to change the concentration. You always want to go from the lowest concentration to the highest concentration, all right? A standard calibration that we use here a lot for VTECs starts with 0.8 ppb and goes up to 80 ppb, okay? It's really easy for us to do this because we have VTECs in different concentrations. So for our purposes, it's 2 mics, 5 mics, 2 mics, 5 mics. Okay, mics is our abbreviation for microliters. Okay, folks, after you do your known concentrations, now we're going to use that to build a calibration file. Okay, so you can see we're inside of our Elvin software. The first thing we're going to do is click on the Calibration tab. Okay, and if you notice all the way over here to the right, there's 2 little buttons. One is an open button, the other is new. We're going to click on the new button for a new calibration. Okay, you can name it anything you want. Put it in a place that you can remember to find it. Okay, once you've started a new calibration file, give it a name that you can remember. The next thing you want to do is come over here where it says Analytes. Okay, once again, you're looking for that button for New Analyte. Click on that. And now you're going to tell Elvin what analytes you're using. Okay, for our purposes, we were using MTBE and VTECs. First, you're going to put in an alias. That's just going to be an abbreviation. Oops. Click OK. All right, you're going to repeat that and add all of your analytes. Okay, just going to use the abbreviation and then type it out. Okay, now I have all of my analytes added. Okay, the next thing that I'm going to do is pull up those files that I did, and we're going to analyze them. So for that, we want to go to the Analyze tab. Okay, this time you want to use the big open button all the way at the top. Now, I told you before that when you run your known concentrations, you run them from the lowest concentration to highest concentration. When I build the files, I actually like to start with the highest concentration and then go to the lowest, okay? The reason for that is just because when you have a big peaks, it's easy to tell what everything is. Here we have the select data file. You have this little window that pops up, okay? In this preview screen, you can see what everything is. That's why it's really, really helpful if you take notes as you go along in the note field. That way you'll be able to find it when you're ready to do your calibration file, okay? So like right here, the one that I have highlighted, that's 80 ppb MB text. That's what I'm looking for. Go ahead and hit select. Okay, and then here's my chromatogram for the 80 ppb. Okay, nice big peaks, very easy to see what everything is. Okay, for the purposes of this demonstration, we're going to be using auto analyze. Okay, there are different ways of analyzing data, and that can be found in another video on our site. But for now, we're going to use auto analyze. Okay, it's going to measure all of this for me. All right. Now I know that right here at 62.17, that's going to be my MTBE. So let's start there. 62.17. Click on that little arrow. Select your MTBE. Okay. Then you come over here and you're just going to add that concentration, which is 80. Okay. This next peak right here at 89.33, that's my benzene. Same thing, concentration 80. Toluene, also at 80. Ethylbenzene, also at 80. Okay, the next one is going to be parametaxylene. Folks, this one's a trick. The frog cannot separate para and metaxylene. So you have 80 para, 80 meta, that comes out to 160. Okay, it's the only tricky one in the group. Last of all is going to be your orthoxylene, also at 80. Okay, now that I've selected everything and entered the concentration, scroll up, I'm going to highlight everything. Right click, okay, and see at the top it says copy to calibration. Click on that. It's going to ask me, am I sure? Okay, it's got all 6 of my analytes on it. I'm going to say yes. Okay, notice how those blue bars appear once I enter in that information. Okay, that is how the software knows what analyte is what. It's going to look inside the blue bar for a peak. If it finds one, it knows that it has orthoxylene or ethylbenzene or toluene, depending on where it comes out. Okay, remember that the order of elution never changes. Okay, MTB will always come out first, then benzene, etc., etc. That never changes. Okay, when I did this, it also moved that information to my calibration file. So now every one of my analytes has a data point for the 80 ppb. Okay, so now we're going to go back to analyze. Okay, we're done with the 80, so let's do the next concentration. Okay, okay, exact same procedure. Auto analyze. Now it knows where everything is, so it's going to fill that part out for me. All I have to do is correct the concentration. 32, 32, 32. For the purposes of calibration, notice it has little guesses in there for you. Ignore that, okay? You are the human, you're doing a calibration, you are telling the software what the calibration is, okay? Once again, remember that very tricky parametaxylene, that's going to be 64. 32 para plus 32 meta is 64. Okay, and then just repeat the same exact step. Okay. Highlight, right click, copy, yes. Okay, We're just going to continue doing that until we get 5 points. Okay, after you have entered all 5 calibration points, or however many you're going to do, you're going to go back to the Calibration tab. Okay, now notice that there's 5 for every analyte. That's what you want to see. Okay, and as I mentioned before, 5 is our preference, but you want to do a minimum of 3 for a linear fit or 4 for a quadratic fit. Okay, so now we're going to take these analytes one at a time. We'll start at the top with MTBE. Okay, if you look down halfway down the screen, you're going to see curve fit options. You want to select area. Okay, the area is much more constant than height, so that's your best bet is area. Okay, then it's going to give you a choice of linear or quadratic. Okay, linear is a straight line, quadratic has a bit of a curve to it. Okay, in an ideal world, linear is better. Okay, however, you should pick whichever fit is best for your analyte, and it may be different for all the different analytes. Okay, down here at the bottom, it tells you what the fit actually is. Okay, so in this case, your linear R squared is 0.99850. That is pretty good. I think I'll keep the linear. Okay, you want to have a minimum of 0.995. Okay, that is the minimum. If your linear isn't that high, you might look at your quadratic and see if that's better for you. Okay, but 0.9985, that's pretty good. I'll take that, so we're going to keep it linear. Then we're going to do the same thing for benzene. Change that to area. All right, linear fit is good. Toluene. Linear fit still good. Okay, now I got 0.999 for ethylbenzene. That looks good. I'll keep that. Parametaxylene. Also linear, very nice. Okay, these are all linear. That's really good news. I'm happy to hear that. But like I said, you'll pick whichever one is the best fit for your particular line. Okay. You'll notice that all those 5 points we did make a graph over here. Okay, that's the line that we're talking about. This is how Elvin figures out what your concentration is. Okay, it looks at the reaction from the detector, at the reactivity of it. It looks, oh, how big is that peak area? Okay, so it's going to measure the area underneath your curve. Okay, and then it's going to say if the area is this much, my concentration must be that much. Okay, that's why this is a critical first step. Okay, the responsiveness of the detector in the frog, it does change over time. That's because the detector gets dirty. So how often do I need to do a calibration? Well, it depends on you. The more you use it and the higher concentrations that you're looking at, the more frequently you need to do your calibration. Okay, one way to check this is to run a known sample. Usually we recommend you do a midpoint, so I could do a known concentration of 16, analyze it, and then look and see how close am I to that 16 with this calibration. And that will tell you how often you need to do calibrations for your operation. Now that you've got the calibration done, all of the analytes are good to go, now you're ready to run a sample.